Well, so you have to do a presentation soon here in CO910. And I fully admit that getting up in front of the class and talking about something is definitely well, a potentially scary experience. And I know you've been doing some presentations in your communications class, but perhaps our presentation in our course will be the first, I don't know, meaningful presentation that you'll be doing at the college. And, that is a little bit daunting. And maybe you were at the class where I introduced doing the presentation and gave a demo, weird little presentation about the Terminator protocol. Of course, maybe you weren't there because attendance has been spotty for many of you. Well, even still, perhaps you're not 100% sure what you should be doing for this presentation. And I thought what I would do to help you with that is give you a presentation. Just give you an example of something that somebody might do for this. You don't have to mimic this exactly. But if you're not sure how it should go, what the flow should look like, how you might want to go about presenting, well, here we go. Here's something that might be helpful for you. What I thought I would do is pick a protocol that's real, but isn't on the list, largely because nobody should be thinking about this protocol anymore. It's got issues, which maybe I should present about. And so I'm going to be talking about this particular protocol, and notice here I've got this slide, which might be something fun to put at the beginning of a presentation as you're getting set up and being ready to talk to sort of set the mood. You don't have to do this, but I kind of like doing things like this. So why don't we get started? All right. Remember, I'm targeting about 7 to 10 minutes, including questions. So let's see if I meet that requirement. Hello everybody, my name is Simon Galton, and my student number, for those of you who are marking me and need it, is, well, it doesn't really matter. I don't have a student number, I'm a professor. Okay. Obviously I'm here in front of the class today, and the path I took to getting here is definitely a longer one than many of you have had. I graduated from a program much like the one that you're taking right now, many years ago, and for over 20 years I worked in industry doing many things, including systems administration, typically on Unix-based systems. I built large computing clusters to solve by giant scientific application, do rendering activities and things, and I managed small and larger teams doing administration and design work in support of engineering firm. I've been teaching here at Mohawk for, my goodness, well over a decade. Now I feel really old. And today I'm going to be talking to you about my chosen protocol, and that protocol is called Telnet. Now, Telnet is, in fact, a very old protocol. It predates me. I know I'm old. It's older than me. It began development in 1969 in RFC 15, and sort of went through some changes and formalization until finally in RFC 97, back in 1971, it was sort of written down exactly how this was going to work. And the last changes were made to it in RFC 854 back in 1983. Now, I keep saying RFC, so I thought I'd give you a couple bonus facts on this. The RFC request for comments system is how any sort of technical stuff or new information, new ideas about internet-related things is proposed and developed out in the open. It's a system that allows for comments from interested parties, for peer review, and it's a really powerful system, and it's been going strong since, well, before 1969, evidently, or maybe in 1969. I do know that the latest RFC number that's active was something that was proposed in February, although I don't think it was actually sort of updated until this very month in March. Its number is 9,367. Clearly, this is an active system. So Telnet is implemented, this protocol is implemented as a service, and you do this with a Telnet server that listens on port number 23, and a Telnet client, although it doesn't have to be done with a formal Telnet client, on the user side connecting to that port. Now you'll notice that I mentioned that we've got this Telnet client, Telnet server, Telnet protocol. Naming a service and the software associated with it after the protocol that it implements is in fact a really common thing. Not mandatory, but very typical. And I think the reason that we do that is because as tech people, we're not often great at coming up with cool marketing names for things, so it's on us. So why is this protocol called Telnet? Well, Around the time that the telnet itself was being created, the most common way that we interacted with a server-type computer was using a typewriter-like device called a teletype. People call it a teletypewriter or a TTY. That was the most common sort of alternate name. I usually either hear teletype or TTY. Okay? Believe it or not, these are not new inventions. The teletype type device first appeared back in, believe it or not, the 1800s to allow the ability to send characters over old telegraph lines. And of course, it advanced over the years until in the 70s was a mature telecommunications device for computers. And it was actually retired by the 80s, by the late 80s, which nobody was sad to see happen because they were pretty clunky devices. The earlier devices looked like a typewriter with a paper going through it, and you would type in your command and hit enter, and it would print it on the paper, and then you would get the response on the computer printed out on the next line. Of course, over time, that sort of evolved. So what you might have seen from an old movie where people are sitting in front of a CRT with a black screen, green text, and they were interacting with it at that level, it would have looked a lot like that. And we would have used a screen for that output and displaying the input as well. Now, Telnet was developed to allow a server to believe that a teletype device was plugged directly into it, when in fact it was connected over a network and was made to appear as if there was a physical teletype device plugged into the server. In other words, the teletype protocol was designed to emulate a teletype running over the network, telnet. I guess it was inevitable. Telnet, well, let's just say that it was a very simple protocol and didn't undergo a lot of updates. Initially, it only needed 7 bits of data to represent the ASCII set that it was sending. But eventually they added the use for that 8th bit. They reserved it for special telnet characters that would control and manage the data exchange on telnet. And because it worked well that way, it was the primary way to access the command line interface on any kind of remote server, proprietary Unix or whatever, from when it was created and released in the early 1970s for almost 30 years until SSH matured as a replacement in around 1999 or 2000, depending on who you ask. Wow, I mean, that's a technology with a long pedigree. So it's kind of interesting to find out how it works. Well, you know what? It's really darn simple. It's maybe one of the simplest protocols I've ever seen. A server, as I said, runs and listens on port 23. Okay, a little program runs listening to a connection on that port. And a client system connects to the server on that port. And the client can sort of configure that communications and say, oh, I'm going to be sending in ASCII mode or later in binary. Nobody used binary mode. It was just for ASCII text. And the client just would take input and pass it to the server. Maybe that was input from the user on, input on the keyboard, or it could have come from another source, but typically we would think of it as stuff the user was typing in. It would send it to the server, either one character at a time, or what we called in line mode, where an entire line of information would be sent, with an exchange. And then the server would send the, text that was generated in response back to the client. I mean, that was the entire protocol. Here, I'm sending you something. Hey, I'm sending you something back. Now with Telnet, there's no what we call internal mechanism for authentication. Telnet just makes the connection and just passes the characters through. If you want authentication, this has to be done by the server itself, just like it would have been if a terminal was plugged into it. The physical terminal didn't have a way for a user to, say, I am authorized to use you. You just plugged in and the server took care of that. And what's interesting about Telnet is it really does emulate a physical connection. Either side of the conversation can terminate the session by logically disconnecting. We used to physically disconnect a terminal if we didn't want that to work anymore. Well, with Telnet, we can just terminate the logical connection. It's just like disconnecting a physical machine. Now, from what I just said a moment ago, as you can imagine, there's a couple of security concerns that were pretty obvious with Telnet. One, of course, is that you're just sending the characters in plain text mode. I send an A goes across the network to the server, and the server sends a 7 back to me. I'm going to see that 7 coming right back. Also, there's no internal mechanism for authentication. As I said, emulating a physical piece of hardware. So these problems compound on each other. So when a user goes to log into a system, the system prompts you for a username, right? And you type in your username. So that, there's the prompt in plain text, there's your username you're responding to in plain text, and then it says, what's your password? And you type it in, and that password goes in plain text across the network. So anybody who can intercept this data, what we call in flight, in other words, on the network as it's going across, will learn the user's login name and their password. And that's clearly a concern that we didn't want to deal with as we realized that network security was a growing issue. Now, although telnet is considered obsolete and shouldn't be used, it's insecure, there are still some places on the internet that support a connection via telnet, things where security really isn't a concern, and they kind of are embracing the retro aesthetic. For instance, gaming, like there's ASCII-based chess bots you can connect to, like freechess.org, where you can play chess with ASCII text. It's very low bandwidth, great for a really slow internet connection where you still want to play chess. And in fact, there's also a multi-user online role-playing games, just like the GUI things, only just using a text exchange, describing what you're seeing, and you issue commands to run around. And if any of you have or will have a professor by the name of Steve Adams, well, make sure you ask him about something called Realms of Despair. Tell him I sent you. Until quite recently, a good demo that I could often do with telnet was to play Star Wars Episode 4, the original Star Wars, via an ASCII art implementation that you could just telnet to the server to get, telnet towel.blinkenlights.nl, if I remember correctly. Now, this service is down right now, but perhaps it will come back online in the future or via some sort of mirror. That would be fun because it was a fun thing to watch. All right, that's all I really have to say about telnet. Are there any questions out there that I can answer about my protocol? No? All right. Thank you very much for listening, and I hope you give me great marks. Bye for now.